Today we're going to find the greatest common factor of a monomial. So if I gave you these two monomials, you would look to see what things go into them evenly, and you'd list out all the factors. So one option is to know that 6 is 2 times 3. So you can see here where we've had 2 times 3, and then we listed out all 5 of the x's, the 2 y's, the 3 y's, which is what we have. We've done the same thing for 2 times 3 times 3 is 18, and then 1x, 2 y's, and a z. And so you can see how I've highlighted them in pink. And so when I go ahead and simplify that, 2 times 3 that they have in common is 6. And then we have only 1x in common, and we have 2 y's in common. And because the first one doesn't have a z, it doesn't have any z's in common. So the neatest way to do this would be to go ahead and make that to the second power. Now, if you don't need to list out all the factors, one of the things that we've been using in class is the factor pair. So I have the first 100 numbers on this page right here, where you can figure out every number that multiplies together to give you, so let's say 56. That'd be like 1 times 56, 2 times 28, 4 times 14, and 7 times 8. So if the number is 100 or smaller, you can use the factor pairs. We're going to do one, and I'm just going to give you an example of one that we didn't talk about in class. Let's say we did 288 and the number 360. And let's say that is x squared, and this one is xy. And we're going to see what they have in common. So one option is to simplify them into numbers that are small enough to get onto the factor pairs chart. So like this one is clearly 36 times 10. Both of those will get on the factor chart, so I'm going to just leave it right there for now. I believe that 4 will go into this one evenly. 4 goes into 20. 4 times 7 is 28, and 4 times 2 is 8. So 4 times 72 is 288. Now I happen to know that 2 times 36, so they have a 36 in common. And if you break down the 2 and the 5, they have a 2 in common. So 2 times 36 means they have a 72 in common. And then, let me highlight it here, you have 1x in common. So my answer down here is going to be 72x. And that would be my answer for this example that's bigger than the hundreds chart. Now the ones we're going to work in class today are going to fit on the hundreds chart for the most part. Write all the powers, circle the ones that they have in common like I did here, and then multiply them together to get my 72. So I'm going to look at 21 and 35. Now again, if I don't know those, I would come over here and I would look at 21 and I would look at 35, and I would see that they each have a 7. 7 is the biggest number that they have in common. So I'm going to go ahead and put a 7 down. And then there is 1 P here, so the most they can have in common is 1. And there's only 1 Q here, even though this one has 2. So there's only 1 Q. And so that's my final answer. Now, let's do one because we haven't done one like this. Let's do it if I have 2 negatives. If there are 2 negatives, then the answer is going to be negative. 15 will divide into both of those evenly. So 15 is my whole number. This is 15 times 3 and 15 times 4. Now, if you look at the letters, this one has 2 R's and this one has 3. That means each of them has at least 2 R's. Notice the second one has no S's, so we just skip it. So can't have any S's in common. And then the T's, let's go ahead and highlight those a different color for you. I have 2 of them and I have 3 of them, so I have 2 of them in common. So it would be t to the second power. And that would be my final answer. It's not any different when there's 3 terms. Notice that they're just separated by a semicolon. But again, 8 will go into all of those because that becomes 4 and that becomes 7. Now we look at our exponents. We have 2 of them here, 2 of them here, 3 of them here. So everybody has at least 2 of them. If we change the color, we can see there's 3 of them and 1 of them and 2 of them. So we're going to go with the one of them because that is the most that any of them have in common. So one way to look at that is you're going to go with the one with the smallest exponent, assuming they all have exponents of the same. So for instance, this one's one where most people are going to tell me 12 goes into them evenly. But if I look at the factor chart, let's see if I can scroll over here and see both of them at the same time. So I see it has a 12, but do you also notice in 48 it has a 24? If I go over here to 72, it also has a 24. So 24 is what they have in common. And they have one X and one Y in common. Even though this one has 3 of each, it doesn't matter. This one only has 1 of each. That's the most that they can have in common. So those are our notes. The second side of this paper is our assignment. So I want to specifically look at a couple that seemed like they were going to be difficult and then they weren't. So if you go down here and we look at, let's say, number 11. Do you see how we have J's here and J here? Oops, let me slide that over a little bit. And then we have M's here and M's here, but they're not in all three. That means there's absolutely no letters in common, and the only thing that goes into all three of them evenly is a 5. So don't be surprised if sometimes there aren't any letters. But on the flip side of that, let's look at, let's say, number 15. I know that 2 goes into all of these because that gives me 7 and 9 and 10. So my number is 2. So let's go highlight them. There's 2 of them. There's 1 of them. There's 3 of them. So the most they have in common is 1 because this one has the least amount. So it's A. Then when we go to the next letter, B, a B, and a B. 2, 2, and 1. So the one in the middle is the one that, again, counts. It's this one. And then C's, we have 1, 2, and 2. So again, there is only 1 in common. So it is very likely that you could have a combination of no letters or lots of letters. So go ahead and finish finding all the monomials.